Hi, in today's tutorial we are going to learn how to classify melanoma images. That means that we are going to take a dataset, skin images, several skin images, and we are going to take this data, prepare the data, and split the data for train and test images, and then we are going to learn how to create and build a CNN model and classify those images according to these melanoma disorders. Okay, so let's start coding. The first step would be preparing the data. So let's create a Python program, and let's go to Kaggle and look for our dataset. We will search for skin lesions images. Okay, this is the one for melanoma classification. As you can see, there are several categories. I can see 9 different categories, and basically when we discover the dataset, we can see that there are a lot of images that are not classified to folders or any names, but there is a CSV file that contains the name of the image and its category upon these 9 categories. So first of all, let's download all this dataset. Let's open this zip file and copy to a new folder. Let's run a fast forward, and then after the zip was extracted, as you can see, there are lots of images, about 20,000 images, different images of skin melanoma, and another file which is a CSV file that has the name of the image and all these 9 categories that has 0 and 1, and each time we have the value 1, it indicates the name of the category. So basically we have first of all manage the data or create a convenient storage for the data. So we will use NumPy and pandas in order to load the data and convert it to our own needs. And we will also import OpenCV in order to do some manipulation on the images. So first of all, let's load our CSV file. As you can see, this is the full path of the CSV file. Let's create a data frame and read the CSV file into this data frame. Let's print the first 20 records. And let's print also the shape of the data frame. Okay, as you can see, this is the data frame, and we have 25,000 of images, a lot of images. Okay, let's create a path for all the images. What we are going to do is import each of the images and create a NumPy arrays for all the images and for the labels. So let's create a list for the categories. Okay, this is the 9 categories, and you can see that we have another false category which is the name of the image, so we will remove it. Basically we are using the name of the columns as our categories. Okay, let's run it again. Okay, now it's correct. We have 9 categories. Now let's create one array for the images and one array for the labels. We will call it 64 because it will be resized to 64 by 64 image. Let's also create a gray image, a black and white image, since I don't know yet for now if I will use if I create a model as a color model, that means RGB model, or a gray model. So as for now, let's create an array of images for color images and for gray images as well. So just to see that everything okay, let's run a for loop for five images, just 5, and let's extract the name of the image out of this data frame or out of this CSV file, and let's print it. If it would be successful, then we will replace this range of 5 to the full list of images. Okay, let's run it. As you can see, we have 5 full names of the images. So we extract it correctly. Let's continue to the next step, and let's load those 5 images and see that they are looked correct and in the OpenCV. So we will read the full name of each of these 5 images and show it. Let's add the wait key. That means that we have to click in order to move from one image to another. So this is the first one, the second one. Okay, looking good. We have 5 images. Now we are ready to continue to the next step, which is running on the full data frame. We don't need to display the images no more, and we can continue for the next step. Let's check if the image was loaded successfully. If not, we will print an error. If yes, we continue to the next phase. Now we will get the relevant label. Since we have 9 columns and each of the columns has a value that is 0 or 1, we need the one value out of these 9 columns. So first of all, let's create a list of values with all these 9 values. Next, we are looking for the position of the value 1. Since each of these values will be 0 and only one of the values will have the value 1, so we will looking for the index of this value 1. And let's for now only deal with the 3 categories, not with all the 9. If it will be successful, if the model will be running, the functionality will be okay, then we can enhance it to all the 9 categories. So as for now I'm only taking the images of 0, 1 and 2. That means that only 3 categories out of 9. Next, we are going to add the label, which is or 0, or 1, or 2, and then we are going to add the image, and before adding the image to the list, we are going to resize it by 64 on 64. As I mentioned earlier, I will also create a list for gray images, so it will be an identical image but a gray image. So let's convert it to gray using OpenCV and add the gray image to another list. So by the end we have one list of color images, one list of gray images, and of course all the relevant label in the same position of image and label. Let's print the name of the name of the image just to see the progress, and we will also print the shape to see that it is 64 by 64. At last, let's print the length of each of the lists, and also I can see now that I have a syntax problem in the brackets, so let's fix it as well. Okay, it will take a few more seconds, and then we are ready to the next step. As usual, all the code will be in my GitHub repo, so you can use it freely. And next, let's convert our list to a NumPy array. This process should be done for the images and for the labels. I think we have too much printing. Let's remark some of these commands. Now it seems okay. Now let's save all the relevant data. So we have to save the images, and we have to save the labels. Let's save it in the main folder. Okay, we will store it here under skin lesions. And the first NumPy will be all the images, and the second saving will be the labels. Let's say okay. One for the gray. Forgot to add the conversion for the gray. Let's do it the same as for the color images. And let's add the saving process, and of course the one for the labels. Now it's looking good. I think we are ready to run it. Okay, let's run the process. As you can see, we are displaying all the images each time that each image is being converted to 64 by 64, adding to the list, and at last all the list will be converted to NumPy and would be saved to the disk. Now it's finished. Good. As you can see, we have more than 20,000 images. Okay, these are the free files. Okay, now we are ready to create our second Python program, which will be building the convolutional neural network model. So let's first of all import NumPy and pandas and OpenCV, and the first phase would be loading our saved NumPy images and labels. Let's copy the names from the previous Python program and load it to all images and all labels variables. let's print the shape of both NumPy variables. Okay, we have more than 20,000 of 64 by 64 by 3 channels, which is the RGB. Looking fine. Now let's create our 3 categories. As I mentioned earlier, we are trying first of all on 3 categories, 0, 1 and 2, which are Mel, NV and BCC. We are not trying the first process all the 9 categories, we only trying the first 3. Let's create our input shape, which would be 64 by 64 by 3 channels. And just to see that all the loading process was successfully, let's take the first image and simply show it. We are grabbing the first image out of the NumPy array, and we would like to present the text of the label and also display the image. Let's also print the shape. We are expecting to see 64 by 64 by 3. Let's put the text, which is the text of the category, Mel, NV or BCC, which are the melanoma categories. Let's show it on the image. We will do it using the CV2 put text. Now we are showing the image and waiting for pressing a key. Let's run it. Okay, this is a very small image, 64 by 64, and here is the text category, which is NV. Cool. Let's try another image number 1. The same category NV, but a total different image. Okay, we don't need this anymore, and let's continue for creating the model. So first of all, we have to categorize the labels. That means converting from integer values to categorical values. We will do it using the keras util functions, np utils. So all the labels will be converted to categorical, and as for now it will be named all labels for model. The number of classes would be 3, but let's create a variable for that as well, which is len of this categories list. Next. Let's print it just to see that we are seeing a 0101 and not 012. Okay, it seems nice. Let's continue. Now we have to normalize the images. All the pixels has values between 0 and 255, and we would like to normalize between 0 and 1. And next we would like to split all the data for train data and test data, so we will import the sklearn model selection, and we will use the train test split. So all the data will be split between xtrain ytrain and xtest ytest using the train test split. This function requires several arguments. First of all the data, which is all the images, then all the labels. Then let's split the data in 30%. That means 70% for train and 30% for test. And now let's print the results. Let's print the shapes of each of these variables, the xtrain, test, ytrain and ytest. Let's print all the data, all the shapes of those data. And let's run it. Very nice. As you can see, we have about 14,000 test images and 6,000 test images. 14 train and 6,000 for tests. So now let's create the CNN model. We will import several keras functions. Of course, it would be a sequential model, and we also import layers like the convolutional 2D, the max pooling 2D, flatten, dense, and dropout. We will also import the module checkpoint in order to save only the successful or the improved training models. I will explain it later. And now let's build our model. So it's a sequential model, and first of all we will create a convolutional 2D layer. The shape would be 64 by 64 by 3. Let's try it with 9 filters, and the kernel size would be 3 by 3. Padding as same, and the activation would be the common one, reload. Then let's add a dropout of 50%. It would be a regulation process to take out 50% of the training. Then we will add a maxing pooling 2 by 2. Now let's another convolutional layer. Let's try it on 16 filters, the same kernel size, 3 by 3, and same padding and activation reload. Once again, let's add a dropout and a max pooling 2D. Now let's add a flatten layer in order to flatten all the neurons. Then we will add a dense layer of 1024 and activation equals reload. And the last layer would be another dense layer with the amount of our 3 categories. And the activation function, of course, would be different, which is softmax. Softmax is the relevant one for categorical model. Let's print the model summary, and I think we are ready to run it. Nice. As you can see, these are the 3 categories and all the layers of our model. Basically a very simple model. Now let's compile it. We will use an Adam optimizer and a categorical cross entropy as loss function, and the matrix will be accuracy. Let's create a batch of 32. If you have more memory, you can enlarge this value. Let's run it with 20 epochs. Let's define the steps per epoch and then the steps for validation. Basically, it's the total amount of data divided by the batch value. Okay, what's left? Yes, of course, we would like to use the model checkpoint. We would like to save the model only if the training was improved from the last epoch. So let's define the name of the saved model. Let's call it best.h5, and we are going to define our file. We are going to monitor the validation accuracy, and we are going to save it only if it's been improved. Save best only equals true. This is the relevant argument. So now we are ready to train the model. We will use the fit function, and we will send the xtrain and the ytrain, which is the images and the labels. The batch size will be our batch size, which is 32. The epochs would be 20, which is the value of epochs. Then let's add, don't forget the commas between each of these arguments. Variables would be 1, then the validation data would be the x-test and the y-test. Let's also add the validation step and the steps per epochs that we defined earlier. And let's also add shuffle in true, since the data was loaded by the name of the images and we would like to shuffle it. And also let's add our best model using the callbacks argument, so each time the model was improved it would be saved. And at last, let's evaluate our test data and let's print the results. Okay, let's run it and let's follow the training. Okay, this is the first epoch. As you can see, each time the val accuracy was improved, it's being saved. And each time it's not being improved, it says val accuracy did not improved. So it will be a very quick process. Let's wait for the end. As for now, the val accuracy is 0.74 or 75. That's a very good result for now. Okay, as you can see, the result is 0.74. That means 74% of validation accuracy. Nice result. Now let's test it on a new image. I've downloaded from Google a new image. So let's create another Python code. Let's call it test the model. This is the image that I've downloaded from Google. And now let's try to predict this image and to see if it will classify it as one of our 3 categories. So first of all, let's import TensorFlow and import NumPy. Also, let's import OpenCV so we can display the image. Let's copy the name of our model file. It's called best.h5. And first of all, let's load our model to this model variable. And let's print the summary of the model just to see if it was uploaded with no errors. As you can see, this is the structure of the model. We have 3 classes as can be classified. Next, let's define our input shape, which is 64 by 64, and our bed size, which is 32. And let's copy our categories. Now let's let's create a function that we call it prepare image, and it will transform our image to be ready for our model prediction. So first of all, we would send an image to this function, then we will resize it by 64 by 64, and then we will use the NumPy expand dims in order to add another dimension for the image. So if we have a 64 by 64 by 3, it will be a shape of 1 by 64 by 64 by 3. Then we'll divide it, normalize it to between 0 and 1. And we, of course, return the results of this image. Now let's load our new and fresh Google melanoma image. Okay, it's called basal cell carcinoma image. First of all, let's read it and display it on the screen. So we'll use the IM show and the wait key for pressing any key to continue. Let's run it. As you can see, this is the image. So the next process will be prepare it from the model. That means we are going to activate this new function, prepare image, and send it the loaded image. And then we are going to run the prediction. So we will use model.predict and send our image, our converted or prepared image for the model, our bet size, which is 32, and the variables 1. Next, let's see the results, and basically we will use the R-marks to get the highest value of all the predictions and get the position of this highest value, and let's print it. That means that we get all 0 or 1 or 2. So in our case this image is 2. 2 means the BCC category, okay, since we have 0, 1 and 2. So now let's convert or let's grab the text of this indication, and let's show it as a text variable. So basically we are going to see the BCC outcome on the log, and let's put this text, this BCC text, on our original image. So we will use the put text, send it the image, the text, the position of the text, the font, the thickness, the color. So a very straightforward process of OpenCV. So let's run it. As you can see, this is the image and the BCC text. Thank you very much. Hope you enjoyed this tutorial. You are welcome to subscribe. Bye bye.